So this is Unit 10, Section 1. In this unit, we're going to talk about arcs and angles. So the first thing I want to do is do a little bit of warm-up and kind of cycle you guys back to old knowledge. So first question I want to ask you is, how do we answer the question, what percent of 60 is 18? Now, if you'll recall that when we do this, there's a couple ways to do it. Typically, the way I do it is I divide 18 by 60. And then I multiply whatever that number is by 100, because that's going to give me a decimal. So when I divide 18 by 60, that gives me 0.3. And then when I multiply that by 100, that gives me 30. So that would be 30%. Now the other way to remember this is when I get this 0.3, I can also move this decimal place 2 places, and that gives me 30. So there's a couple ways to do that, as I said. Number 2 says what number is 44% of 6, and in this one again we have to turn that 44% to a decimal. So we're going to turn that to the decimal point 0.44. So again, what we would do is here we would move the decimal places 2 places to the left right there, and then we're going to multiply that times 6. When we do that, we get 2.64. Now number 3 says find the measure of angle WVX. So WVX is right here. Now I want to talk to y'all about pie charts. Pie charts, when I have a pie chart and I add up all these numbers, 30 plus 29 plus 41, they equal 100%. And I also know that a circle measures 360 degrees. Well, this is asking me for an angle. And I know that this angle right here is 29% of the whole circle. So I'm going to multiply 0.29 times 360, and that's going to give me the measure of that angle, and that's 104.4 degrees. So once again, just refreshing y'all's memory on how to do problems like this, because these are the types of problems with percentages that we're going to deal with in this unit. So let's look at this first concept. It says a central angle is an angle whose vertex is at the center of a circle. So we're talking about a central angle, so let's go ahead and draw two sides of an angle. So from there to there. Now I'm going to say that this is a 90-degree angle. So that means the central angle that I just drew, its vertex is at the center of the circle, if you notice here. That's where the two sides of the angle come together. So that's a central angle. Central angle's vertex is at the center of the circle. Now, when we talk about arcs, our arcs are out here. This is the part of the circle that is basically enclosed by that angle. So when we talk about that arc, it's going to be equal to whatever that angle measure is. So we knew that this was 90 degrees. The angle was. We also know that the arc is 90 degrees. So with central angles, arcs and angles are congruent. Now that's not going to be true later in the unit, but for right now, we know that arcs and angles are congruent. So let's go on to this next concept, which has to do with minor and major arcs. So a minor arc is an arc that basically is equal to the measure of the angle. So right here we have this angle, and we're going to just say this is 60 degrees because I know most of y'all do better with numbers. That means that the arc here of that angle is AC. It's this out here. So the arc and the angle are congruent. So the arc AC is 60 degrees. Now when we talk about the major arc, and by the way, a minor arc is designated by 2 letters, whereas when we talk about a major arc, we always say a major arc with 3 letters. So down here with our major arc, it says it's an arc whose points are in the exterior of the central angle. So now we said before that this was 60 degrees. Now the major arc we're going to talk about is right out here. So that's ADC. And I always do these in the order that it's written. So I go from A to D to C. So in this case, if we're looking for the measure of this arc, we know that it's everything but 60 degrees. So we can say 360 minus 60, and that means that this one would have been 300 degrees. Our third point down here is if the endpoints of an arc lie on a diameter, the arc's a semicircle. So basically, half the measure of a circle is 180 degrees, so a semicircle's measure is 180 degrees. Down at the bottom here, it says, given 2 points on a circle, the minor arc is the shortest arc. linking them, and the major arc is the longest arc linking them. All right, so remember this, that in minor arcs are named with 2 points. Major arcs and semicircles have to be named with 3 points. All right, so the circle graph shows the types of grass planted in the yard of one neighborhood. So we're talking about a whole neighborhood, which would be 100%. So if you notice, we have these percentages in this problem. So all of these percentages, 65, 28, and 7, if I were to add all those up, they should equal 100%. So what we're going to look for now here is to find the measure of arc KLF. Again, we're going to do this in the order that it's given. So we're going to start over here with K, and we're going to go around to L, and then all the way around to F. So if you notice, it has to do with this part of our pi. Now, I notice over here that this is 65%. So again, we got to turn that 65% into a decimal. So we're going to do 0.65. We're going to multiply that by 360 because it's asking us what is the measure of the arc. And to find the measure of the arc, we have to do the percent times 360. When we do that, if I recall, it was 234 degrees. Yeah, it was 234. So 234 degrees. So I want you guys to go ahead and try to do these check it outs and then come back to me. So A for check it out example 1 was find the measure of angle FMC. So with FMC, we've got F over here to M and then over here from M to C. So this is the angle we're talking about, this whole thing right here. So we're going to have to add the 9 and the 10 and the 11. Now I like to go ahead and just add these numbers together and then turn it into a percentage because I'm less likely to make a mistake by doing that. So I'm going to add 9 plus 10 plus 11, and I know that that's 30. Then I'm going to move my decimal place again 2 places to the left, so that's going to be 0.3. So when I'm trying to figure out what is the measure of the angle, I'm going to multiply 0.3 times 360 and get the answer. That equals 180. Sorry, 108. My bad. 108. All right, so the next one, I'm going to go ahead and erase this and so we can work through this next one. So the next one is asking us about arc AHB. So once again, I'm going to draw this arc on the outside of my circle. So it starts at A, and then it goes around to H, and it goes all the way around here to B. So that is all of that. So I'm going to go ahead and shade it in for y'all so you guys can see it. So it's all of this. So now there's a couple ways I could do this problem. Now I could definitely add up all of those percentages. So that would have been 26 plus 3 plus 3 plus 9 plus 10 plus 11 plus 13. And when I did that, I would have got 75%. Now there's another way we could do this too, because I notice everything's included in this except for that 25%. So I could have also done it like this, 100 minus 25, and that is again 75%. Now we need to turn this into a decimal again. So we're going to do 0.7 times 360, and we multiply 0.75 times 360. That is equal to 270 degrees. All right, so our last one that we're supposed to find here is the measure of angle EMD. So down here, I'm again going to draw these sides, E to M, M to D, and I notice that that's 10%. So we're going to multiply 0.1 times 360, and that is 36 degrees. So probably the biggest challenge in this is making sure that we draw our arcs and our angles properly so that we can figure out what percentages they actually map to. So the next concept we're going to talk about are adjacent arcs. These are arcs that are in the same circle that basically are right next to each other, and they share a point. So you'll notice up here that arc RS right here is adjacent to arc ST. And if we were to add these two arcs together, we would get arc RST. So let's talk about this concept a little bit more down here. So we're going to now talk about this arc addition postulate. So if we're trying to find arc ABC, the whole thing here, then to get that we have to add arc AB to arc BC. That's how we find the whole arc, and we call that the arc addition postulate. So down here, for example 2, it says find the measure of arc BD. So we're looking for this arc right here, from there to there. However, before we do that, we have to find all the measures of these angles. Now this, I need you to notice that this is in degrees now. It's not in percentages anymore. So we know that when we add up all of these, they have to equal 360 degrees. So I want to talk about what I see first. So in this drawing, the first thing I see is that I have a pair of vertical angles. So I see that, and that means this angle over here is congruent to that one over there. So that means this one is 97.4 degrees as well. Now I also notice that I have a half circle here, a semicircle. So I have a semicircle right here, and so that means that I should be able to find AFB, this angle right here, AFB, by subtracting 97.4 from 180. So I'm going to do 180 minus 97.4, and that is equal to 82.6. So I'm going to go ahead and put that back in here, 82.6. Now I also notice, again with these, that I have some vertical angles here, there and there. So I know that this and this have to equal each other. Well, if that's true, then I should be able to find DF, this angle right here, DFC, by subtracting 52 from 82.6. So 82.6 minus 52, and that's going to equal, let me go ahead and do that. 82.6 minus 52 is equal to 30.6. So that means this one right here is 30.6. So let's go ahead and rewrite this so it's a little bit clearer. So, okay, you recall that the question was, what is BD? So from B down here to D down here. Now, I went the shortest distance from B to D, not the longest distance, and that's because it's 2 letters. So here again, and this one was 97.4 degrees. So what I have to do is add together those 2 angles to get the whole. So that's going to be 97.4 plus 30.6. And let me go ahead and do that. 97.4 plus 30.6. That equals 128 degrees. All right, so now I want you guys to go ahead and see if you can find me the measure of arc JKL and the second part of this problem as well, but go ahead and fill in your diagram first. Find all the missing angles first. So first thing I notice is that I have a pair of vertical angles here and here, so this is 25. Then I notice that I have a semicircle right here. So I could add the 25 and the 40, that's 65. Subtract that from 180, minus 65. That gives me 115 for this one up here. Have the same thing down here, only this time it's 25, so I'm going to do 180 minus 25, and that's 155. So now that I've found all the parts of this, now I can find what it's asking me for. So this problem is asking me for the measure of JKL. So I'm going to again go in the order that it's given. So I got J here, I got K there, and I've got L up here. So what I notice is that this is the part we're talking about. So we're going to add 115 to 25, and that's 140 degrees. Next, so the next part of this problem said find the measure of LJN. So here again, I'm going to mark LJN. So L is here, J is there, and N goes all the way around to here. So we have got all of this included. So we got everything that's marked here. This is everything, right? So that is everything but what? So we could add up all those parts. We could add 115 plus 25 plus 155, right? And that would give us a measure. Or we could add these two parts together, the 40 plus the 25, and whatever that number is, we could have subtracted it from 360. Again, you can do this either way, doesn't matter. So what that's going to give me, no matter which way I go, is 295. Because 65 from 360 is 295. And when I add up these numbers up here, it is also 295. So that is the measure of that arc, LJN. So the next concept we're going to talk about is when we have in a circle, congruent circles, congruent arcs, the two arcs have the same measure. So if I tell you that arc UV is congruent to ST, then I know that they are the same measure, and I know that the angles that are their central angles are also the measure. So that means that angle X would be equal to angle X. The next concept we're going to talk about are arcs, angles, and chords. So in this problem up here, it says that if these two angles are congruent, then their corresponding arcs and chords are congruent. For the next one down here, it tells me that if the chords are congruent, and you notice that we have got tick marks on here, so if these two chords are congruent, then I can say that this angle is congruent with that angle, and that arc is congruent with that arc. Down here on the last one, so this last one says, in essence, that if the arcs are congruent, then the chords that correspond to them and the angles, the central angles that correspond to them, are congruent. So what you need to remember here is that if arcs are congruent, then if any one of those three things is congruent, then the other two are. That's what you need to remember. Arcs, angles, and chords that are corresponding. If one of them is congruent, then the other two are congruent. So let's go ahead and work a couple problems. So on this one, it says TV and WS are congruent. So TV and WS are chords. So if the chords are congruent, then we know that their corresponding arcs are congruent. So that means I know this arc right here is congruent with this arc right here. So we're going to go ahead and set those two equations equal to each other, and we're going to solve. So we're going to subtract 7n from both sides. We're going to add 11 to both sides. So then we're going to divide 2 into 22. That gives us 11 for n. Now recall that when we do these problems, we have to plug that n back in. So we're looking for WS, so we're going to do 7 times 11, that's 77, plus another 11, that's 88. So the answer is 88. Now I need you guys to also recall that we can check these because these things are equal. So here I'm going to do 9 times 11 minus 11, that's 99 minus 11, that's 88. So if both of these measures were 88, this was 88 down here too. If both of these measures were 88, then I got the correct answer. So this is another one of those kind of problems where you guys can check it. All right, so let's look at the next one. On this one, we have that the two angles are congruent. So if the two angles are congruent, then the two chords are congruent. So here again, we're going to set them equal to each other, and we're going to solve the problem. So when we do that, we're going to subtract 5t from 14t. That gives us 9t. We're going to add 26 to 1. That's 27. We're going to divide both sides by 9. That gives us 3. Then we're going to plug that 3 back in. And again, we're looking for nm. So 3 times 5 is 15, plus 1 is 16. And again, want to remind you that we can check this. So right here, we have 14 times 3 minus 26. That's 42 minus 26, and that is another 16. So make sure you check these answers when you can. All right, so this time on this problem, go ahead and put me on pause. Go ahead and work this problem and then come back to me. Now, you'll notice that I've already got drawn up here that when ray BT bisects angle QPS, it makes those angles congruent, because anytime we bisect something, it creates two equal parts. So if the angles, again, are congruent, then we know that their corresponding chords are congruent. So we're going to set the chords equal to each other. And when we do that, we're going to add 4x to both sides. So that gives us 10x equals 20. Divide both sides by 10. That gives us 2. Plug the 2 back in, and 2 times 6 is indeed 12. And again, let's go ahead and do this over here just to do our check. So 20 minus 4 times 2, that would be 20 minus 8, that equals 12 as well. So again, quick way to check your answers to see if they're correct. All right, so the next problem, the last one, go ahead and do this, and again, come back to me when you're done. So here again, we notice that we've got two chords that are congruent. So if the two chords are congruent, then we know their corresponding arcs are congruent. So we are once again going to set these two equations equal to each other. When we do that, we're going to get 5y is equal to 20. And we're going to divide both sides by 5. So we get 4. And then we know that 25 times 4 is 100. And again, let's check this up here. So this would be 30 times 4 minus 20, that's 120 minus 20, and once again, that is 100. So that's our check to see if we got the right answer for both.